I'm going to give you a definition of that one. Okay. So Poisson random variable. Okay. And again, it will be x. Okay. And it can take values from 0 to positive infinity. 0, 1, 2, all the way to the right. Okay, but only integers. Okay, so this is the set. Thanks. So I'm going to use these curly brackets to denote that these are all the possible values. So the set of values that this random variable can take. Okay. Now, what is the probability mass function for this Poisson random variable? F is the probability that x is equal to x, small x. Now it's going to be equal to some parameter lambda to the power of x exponential to the power of minus lambda divided by x factorial. Okay, so this is the expression. Okay, it may look complex, but it's not really. So this lambda, it's a parameter. It's an intensity of Poisson random variable. Okay, so it was so Poisson random variable was discovered and studied by, I think Simeon was the first name of this mathematician, Simeon Poisson. He was a French mathematician, and he was basically counting events. So he was looking, maybe the number of flies that come into the room and fly out. Okay, and he was counting how many of those events happen in per unit of time. And it's obviously a random variable, and it turns out that this kind of events is described by Poisson random variable. So the probability that it's going to be one fly is going to be just plug in x equals 1 here. It's going to be the probability. 2, we plug in x equals 2. Okay? And of course, the more intense, motion of flies, the lambda is going to be greater. Right. Now, let me show you how this probability mass function looks.
I have a question.
Yeah.
Is this something we were using in our class?
This one, yes.
Yes.
You will see it probably 5 lectures from now. We'll have to do with queues. Turns out that customers come to a retail store. So instead of flies, it will count in customers who come, say, per hour. Also Poisson random variable. Very interesting. If you count in sales, say you're selling CDs on the internet, and you count in how many sales you're going to make per day, that is going to be a Poisson random variable. So this is why it's important. Now let me show you how it actually looks. Okay, so here I have my parameter lambda equals to 4. And here I have the formula.
So we can see it.
Cannot see it. Very strange. Now you can see it, right? So this is the probability probability mass function of the Poisson random variable. Here I have my parameter lambda that's equal to 4. Okay. Here I have all the probabilities. This probability mass function computed. By the way, if you open this Excel file Bootcamp XLS, it's there. And the Poisson PM CDF. Okay. So these are the probabilities defined by this formula. Here I have cumulative distribution function. Now, and here I actually compute average of the Poisson random variable and variance of Poisson random variable. Okay, but I'm going to tell you how to compute average of random variable, expected value for random variable, just like that. Okay, so this is how the probability mass function works. See, it's kind of this bell-shaped with tail going to that direction, but it's going to get very, very thin very soon. And here's how the cumulative distribution function works. Okay, so this red bars is the cumulative distribution function. And you see that again it reaches 1 and stays at 1 forever. Okay? Basically representing the total probability is going to approach 1. So this is what the Simeon Poisson came up with, okay, among all other things in his life. Yes.
I'm still a little unclear about what the Poisson random variable equation is. Like, when do we know to use it as opposed to another equation?
Well, when do you know? So it's something that has to do with counting events. So I give you a few examples. Like if you count the number of sales that you make per day, that will be a Poisson random. Okay.
Okay. So what would be the x in that situation?
X is going to be a random variable. So you look, number of sales that you can make per day is a random variable. You can make 0 sales. You can make 100 sales. The question is what is the probability of those?
Oh.
Right? And this gives you the probability. All right. Now, I want to compute something called expected value of random variable. So in this is something really important because if you have something like demand, and you recognize it's random, but you really want to know how much on average you're going to sell. Okay, so very, very good question. So for that reason, we define something called expected value. And I think it's okay if I write it here. So expected value of random variable x. Well, we know it as e of x. Okay? And it's just a sum of all possible realizations of this random variable, all possible values that this random variable can take. Okay? Multiplied by probability that this random variable is actually equal to that value. Okay? And you sum over all possible i's. This is going to get you an average. Okay? And this is, by the way, why this probability mass function is important. Okay? So it's important just because it describes, but it describes the random variable. It's also important because it actually you can use it to compute things like averages. Okay, well, example. So for this random variable, expected value would be 20 times 0.1 plus 25 times 0.3 plus 30 times 0.5 plus 35 times 0.1. So if you add this up, it's going to be 2 plus 7.5 plus 15 plus 3.5. So this is going to be 11 plus 15, 26 plus 2, 28, right? Yeah.
Just a quick question about the Poisson random variable.
Yeah.
Is the lambda described to us, or do we find?
Yes, lambda is typically given to you.
Okay.
Okay, so that's the intensity. Like, in fact, it turns out that this is your average intensity, okay, average demand. Okay, I'm going to show it to you in a second. Okay, so once we know that, and we have our Excel, we can actually compute what is the expected value of Poisson random variables.
What does lambda stand for? What does it represent?
It's called intensity, it's a parameter really. Okay, so if you think about average number, if you think about sales per day, think about intensity of this customer's arrival. So how many customers per day usually come? That's what it is. So here I have my values. Okay, 0, 1, 2, and here I have the probability. Okay, so when I compute my expected value, I just use this function, Excel function of some product, which basically takes these pairwise products and adds them up. And you see, so here I have this column and this column, multiply them pairwise, add them up, and the result turns out it's actually equal to 4. Okay. So the average of this Poisson random variable is actually equal to the parameter, to the lambda, to the intensity. Okay? Yeah.
Is this usually the case, or is this just?
It is usually the case. In fact, I can change this to 3. Let's see. Sorry, calculator, average of 3. I can change it to 5. 5. And change it to 10. So it's going to be very close to 10, okay? Because here I need to, my tail grows bigger, okay?
Does that mean you can actually determine lambda by like calculating expected value?
No. Usually you know lambda from measurement, but you calculate your expected value by using lambda, because to compute those probabilities, you need to know lambda. Okay. Okay, so this is the average. Now there is also something called variance of random variable. Okay, so variance is it's a measure of dispersion. So I'm going to give you an example, an illustration, right? So if we have this Poisson random variable, probability mass function looks like that. Okay. Well, variance is like this width of the distribution at half, at the half, right? Half of the maximum. So something like that. Again, it's not a rigorous definition, but it just gives you an idea how it's related to this width of this distribution. Now, how do you compute it? So what is the variance? Well, variance of x is defined by expected value of By the way, you probably should have, you should have seen this in statistics class. Variances, standard deviations, this square deviation. So this is the definition for variance. Okay. So what I do, I take my random variable x, I subtract expected value of x. Okay. Then by itself it's going to be a random variable. I square it. Okay, and then I take expected value of that square. Okay. Now you can use this, but you can simplify this formula to this. So it's actually, you can expand this square, which is the square of the difference. Okay. And then you can use the property of this expected value operator. The property is like this. It's an important property. Is that expected value of sum of two random variables, x and y, is equal to the sum of expected values. Okay, that's the property. And I'm going to use it, so it's going to be e of x squared minus 2 ex times ex plus ex squared. Okay? Now you notice that this guy is actually the same as this guy, it's just factor of 2. So I'm going to simplify it further. Expected value of square minus square of the expected value. So this is really the variance. As an exercise, you can calculate variance of this random variable. It's not super difficult. You just need to compute the expected value of the square of this guy and just subtract the square mean. Okay. I'm going to show you something about the Poisson random variable. Can I put the word down? Yeah. Question? I'm going to show you something about variance of the Poisson random variable. So here is my formula. Okay. So basically I'm computing the expected value of the square of the variable minus square of the expected value. Okay. And here see I have this all the squares, all the squared values. So 0 is 0. If it's 1, it's 1. If it's 2, it's 4. If it's 3, it's 9, etc. And I compute expected value of the square. Okay. So I multiply these guys by the probabilities, and I subtract square of the expected value which I have computed earlier. Okay. And it turns out that for Poisson random variable, turns out that for Poisson random variable, the variance of this random variable is actually equal to the mean, and it's also equal to this parameter number. Again, some neat property of the random variable.